Another point I wanted to make by way of intro, two of my colleagues, Christian French and Laura, where are you? Okay, let's see you now. Laura's actually working with Quilt directly. But Christian and I were the main contributors to what we're seeing, and Christian's fingerprints are all of this. So I tend to be the talking head form, but you'll notice Christian's works throughout. So if I don't give her a nod to Christian, like I might be TFD, it's okay. I'll take the liberty of saying Christian's in a similar situation where both of us, all three of us, coming out of Celsius. Celsius is a great place to be, and they really took care of people. But we are definitely open to discussions, and I know Christian's as well. So Kevin, thank you for being brazen about that. Not you were brazen, but appreciated, much appreciated, and I think all of us appreciate that. So, all right, enough setup in the 30s. So you notice I crossed out the data. Most organizations that start with the concept of provenance do start with data provenance. For us, and I think it's become more common now, provenance means more than just data provenance. It's talking about what went into something, what comes out of it, and the ability to capture not just the raw base by but also the environment and the code that's being run. A very common answer you hear from people in almost any situation with dealing with vendors, and I've been on that side too, so I'm not, I'm trying to keep my hands too clean on this, is we're always deal everything with us, everything's going to be fine. Just stay in our environment and it's all perfect, right? Just buy all our stuff and drink all our Kool-Aid and then you'll be great. We all know that's actually not possible. So what we did was to look to design a system that could be flexible across the entire infrastructure we had, take into account all the weird corners of our environment, and in a way that could be flexible moving forward. So those were some of the things that were driving what we meant by provenance. The why we care about it really is two things, and I actually don't know the makeup of the audience too much here, but I would imagine most of you folks can understand the split between why you do things internally and then why you tell other people you're doing things. So for us internally, we had one set of requirements. The one set that set of requirements we gave to the rest of the company were things like filings. We ended up with one drug to win phase 1. That's great. We got more that were in the pipeline. We wanted to be ready. We wanted to be ready to answer questions around where did those results come from. From a data side, we want to be able to handle that with no question. From my side, I like to be ready for any audits. I like equity events. So if you do have an equity event, someone comes in this, from an acquisition perspective, an investor perspective, you want to be able to answer their questions without any hesitation, without any question. And then there's a very practical reproduction requirement. Okay, we like those results. Let's check what happens if things change just a little bit. Here we regenerate those results. So there's some things that are valuable to the company. And internally, I wanted to drive with Provenance something that was not quite as obvious to maybe other parts of the company, which was somewhat selfishly, Christian and I were just talking about this. We always want to take on new technology. We always want to take on new challenges. So what we wanted to do was enable our own technical innovation, but also for the likes of Laura, who she made that, I might have cleaned out. For the likes of Laura, there you are. Put your head down. But for our customers, we wanted to keep them moving fast, right? So we wanted to build a system also that would accelerate innovation. That's sometimes tough to sell to the rest of the company, but internally we want to generate that. We tend to build things as core services. So for us, Provenance as a whole was core service that we could leverage not just for its own purposes, not just the producing for audits, filings like that. We wanted to use it as a service on its own. Meaning when you look at Provenance, you can do more with it. And one of the little hidden methods that we found was that it opened up some capabilities for our CompBio team to do things and use Provenance in a way. It almost became like a temporary investigation space because they could store artifacts in a very simple way, reproduce things, go back and understand where things change. It actually accelerated some the investigation side of things. And then lastly, the thought factor, you're not supposed to do it, but when you go to anybody else and you explain what you're doing, if you go in with a big a set of documentation, something that's convincing and something that is solid, they're more likely to believe you that it takes a lot of hand waving and sort of explanation, right? So I wanted, from a provenance perspective, I want us to be able to say, for a certain set of results, here's the provenance, and go, oh, that's it. And I wanted our eyes to gloss over it. So just to be completely honest, so everything in that set of documentation proving the provenance would be fact. It would be real. It would be backed up by full records that would go into that thought factor. But I didn't want them to have to look. It's so much easier when you can just say, hey, it's done. And they look and go, wow, yeah, that's a lot. All right, thanks. And they go away. So those are some of the things that were the goals that we had. From a design perspective, this is where, as architects, the data and software architects, we really wanted to focus in on these as principles, for instance. We wanted to build something that would be minimal impact. I think everybody is familiar with when you build something great and all it takes is someone to take these 12 steps before they can leverage it. They're not going to take those steps. So you really have to reduce it down to a bare minimum of required interaction. So one of the principles is keep the surface area low and keep it simple and keep it understandable. Basically, in natural language, you describe what you want to do and you maybe have a few calls, and then everything just works. So minimal impact. We had to work across multiple environments. So this was from investigation perspective. We happen to be on EC2s, Dockers, MacBooks, various environments. We were operating in batch up on ECS, on again, other EC2s, other clusters, different scheduling environments. So we had to kind of go across multiple environments, Lambdas, and so forth. During automation, so we had plenty of automation that was getting our results, and we also had investigation. But during automation, there should be no other impacts on the system. We obviously had to instrument the automation code to make it work. But once it was turned on, it should just go. And in the same way, you should be able to turn it off, which we had to do a couple times. Read into some things where we realized, our design wasn't quite perfect, configured. And so we had to turn it off. So that minimal intervention made it very easy for us to turn on, provenance, turn it off. And then when there was interaction, the interaction should be very intuitive, so that as I mentioned, it should be very readable, like start provenance tracking, turn off provenance tracking, add to provenance, things like that. We like to leverage services, so we're in the house of AWS. We leverage AWS services throughout the system, but also internally developed systems, services that we had already built. We wanted to keep the cost low, so when you're not using it, it doesn't cost anything. Well, not quite nothing, but very low. We didn't want to have lots of systems up and running 24/7 when you're going to be using them for 3 hours a day. So cost was kept low, and then lastly, obviously, scalable design. You can't go big, but on that part, there's a last little bit there that we wanted to build something that could scale big, but build it to work now. And that compromise is often you don't implement your full design, right? But we wanted to leave the spaces where you could put in additional services or different services and increase your scale. Move through this quickly. First one, obviously, Quilt. Most of you know Quilt here. If you don't know Quilt, this is not because they're paying me lots of money to stand here, but they're really good people and really smart. And over and over again, as Kevin alluded, we would need something, and the conversation that we would have with Quilt would sometimes go, well, we don't have that yet, but let's talk about it. And so the conversations with Quilt were valuable, in part because sometimes we were directly consuming Quilt products, but most critically because they were honest and intelligent and informed partners in our development. So Quilt was absolutely critical to that. And I'm not sure if you guys know a company called Code Ocean, smaller company, a little bit newer. They were closest to where our vision of that provenance was, but they made some architectural choices, and they had the as long as you're inside of our umbrella approach, or 10, so I don't know which film analogy I'm using there. But they were closest, so we had a lot of good interactions with them. We actually evaluated them for a while, almost went with them. So I do have to give them some credit for helping us work through some concepts. All right, what are these concepts? These are mostly in order, but I will apologize because I have not given this thought before, so I might find myself needing to go back, refer it all. I didn't want to jump ahead. One of the important parts is the concept of a session, and that Provenance isn't a single activity on a single machine where you're gathering information from a single set of code. Right? It's a conceptual session where it cuts across multiple memory spaces. It can span time, can span almost any amount of time at any amount of system. For me, being around for a while in the industry, it feels a lot like a distributed transactions system, right? Where you're starting a session and then you're contributing to it, and maybe you're changing some aspects of the session, and then someone along the way needs to commit that session. So the concept of the session was pretty core to what we built out. Another one is the activity, and that's a very generic, what are you doing? And Christian did a really good job of actually delineating a lot of code to model activities around all the different things we did. Scripts, notebooks, processes running up a batch. Almost anything that we could run, we could throw an activity on top of it. In a sense, you think of these as agents that can interact with Provenance system, but that activity was capturing what was going on, inputs, outputs, but also where it was running, what it was using. Part of that is compute environment. Compute environment, obviously things like Docker and EC2, but also details about what you're running on it. Most folks of you will probably recognize that if you're running some code on a CPU versus a GPU, and the underlying code you're using can recognize that difference, you might get different results. You might see slightly different results. We've had plenty of things where the memory handling on GPUs is different, right? Because they move things into the GPU memory space or out, and that movement, you actually might get different results. We'll deploy things so we have very critical results when you move from GPU to CPU. That's a small example, but you have to capture all those little aspects so you know with Provenance, given the environment, what you're running on. So we're capturing all those in logically something called compute environment. Code artifact talks about the actual code you're running. Your code, where you are in your commits, as well as all the underlying libraries that would go into the package. So what got installed, what bring in with Pip packages, what other underlying OS level packages did you bring in? So we needed to capture all those things within the code side. And then finally, the data artifact, Quilt is a breeze. Quilt's tracking, its core of what we do is to, we lean on their concept of packages and versioning throughout our system. However, not everybody can do that. So the data artifacts include things that would be easy to include, but also sometimes seems weird, like Slack messages. So we use Slack for a lot of notifications on what's happening within our system. It's a very convenient way of just letting people know. Blast you out some messages to someone interested that they already have their Slack open. So, your report's ready. Well, we should capture the fact that we sent out that notification, but it's weird to put a Slack message in Provenance. But it's relevant when you go back and you say, well, what was this activity and what did it produce? Well, it produced a notification. That's important. So we would have a lot of the data artifacts wrapped. And if we could, we would reference the data artifact where it's at. So again, Quilt being a breeze, so you just point a package, point a version, point an asset within the package, everything was great. S3 version buckets, we did version buckets everywhere. That also was pretty easy. And we just referenced those, and those became soft links essentially. But what about a data frame? The data frame generated. So, and other in-memory or let's like notification side. Those we actually built it so that when you register them, we would make a copy of them. And so we would actually bring that into the Provenance system as you go, so that we would have the record of it at the state in memory at the time of capture, or at the time of commit, at the time of the different checkpoints of our Provenance session. And that would go into yet another Quilt bucket. So I think most folks here work, you find yourself dropping buckets all over the place, right? Like, well, let's just make a new bucket. And we found ourselves doing that. And so we had Provenance inside, we had Provenance data that was captured for in-memory as well. And then lastly, one of the things that it shows up in a couple other slides, but I do want to make a point that I talk about all these assets and all these different pieces that are captured within these key concepts here. And one of them is our URI. So everything in our system, I think we probably got to like 90%, maybe a little around there. All the data in the system, everything written out can be referenced by URI. So you can know where something is by an external reference. So that it would make it easy for us to track into Provenance sessions just by writing simple strings, small strings, to create a list of assets, and that list of assets could be dereferenced into the actual physical assets. So those are some of the key concepts. What we did from a high-level architecture, actually, before I go into this, I'm going to switch a little bit into the actual implementation and get some intro there. Okay, good. Doing okay on time. But questions on this so far? Which is fine, because I'm talking a mile a minute. Okay, so this is the box of life, right? This is the architecture diagram, but it's pretty relevant. So we did capture data from multiple pipelines, multiple automation, or interactions, interactive analysis, and then also we have our internal portal, which would allow us to interact with, this was actually a future piece, but interact with that Provenance data. But the Provenance was represented internally, but interacting through API, it was represented internally through graph representation, where the nodes were the different components, the different concepts that we have here, and the edges explain their relationships. So you can move from node to node through the relationships, and this property graph would describe our ultimate Provenance session. The reason we did this is we wanted to look at Provenance not so much as just the thud factor, just print out the report at the end, but also to pick an asset and then be able to go and find what that asset is related to, how it's been used, where it's been used, and understand the impact of if we change something in that asset. So if we make a piece of code change, ultimately one of our goals was to say, if we change this piece of code, this line of code, what would be impacted? What results would be affected by that one change? So that involved us being able to track where that piece of code existed, walk the graph to find all the implications of a change, and then be able to say, okay, if we're going to make this change and we think it's significant, this is what we're going to have to redo. So for us, Provenance wasn't just the presentation or the thud factor, but also understanding in a very dynamic way how are things connected. And so it did impact, let's say we want to upgrade a particular Python package we're using, what is the impact of that package on public? So that's where the property graph became critical, right? Just to be able to walk that, obviously, you could represent that in different data structures, but the graph is a natural one for that. That graph also is where we did the majority of our interactions. So the APIs weren't hitting S3 directly off the times. They were interacting just with this property graph. We implemented that first. Not every word, Christian, but for moving us onto Dynamo, which is a weird choice for a property graph. We had some internal code that made Dynamo very easy for us to use. We had our infrastructure set up nicely around Dynamo. We got security groups made. You don't want to go back to IT and have to explain why. You need to open up all sorts of other services and create all these other roles. We just hopped up Dynamo because we could do that already. Turns out Dynamo is pretty good at this. They're not great, or at least not great, but it is pretty good. So that's an example where we were able to implement something very quickly up front, but the plan was to move that when it reached a scale where Dynamo could no longer handle the load, to move that over to a dedicated graph database, like an Aptos thing. Again, a huge tool, a lot of AWS. So that was a good example of building for now, architecting for the future, and the interaction with that graph was built through APIs that hit the actual storage mechanism, so that ultimately someday we could have librated off. We didn't get there, but that was the design. Quilt became not only a source of the actual data results that we were gathering when we did analysis, but also the repository for our Provenance data that we were capturing. So things that needed a persistent version, long-term referenceable storage were being stored in Quilt. And this is one where we didn't get to do one to leverage some of Quilt's display capabilities and go in and instrument our readmes or the lighting pages for the packages to be able to present Provenance for packages right when you're a package so you understand the impact. That we didn't get to that point, but we were planning on leveraging Quilt for that. That is pretty much it on the architecture. I'm going to make another pause here real quick. Any other questions on this? Yeah.
Would it be used for your in-memory property graph? So was it a visualization that you did directly on a database?
So we unfortunately didn't get to the visualization side. It was an API walk the graph through an API type situation. So it would come in memory, but one of the important things is we did a lot of lazy loading. So you would bring a node into the graph, that node would have references through the edges into other parts of the graph, and you could then walk that graph, which is one of the examples that I have here.
So it was in RDF?
No, it wasn't. It was actually, we didn't represent the graph through that. It was a basic, just in Dynamo structures.
Okay.
So yeah, we'd load a JSON and it would just reference another node. There was. So personally, the standard node represented the graph representations tend to be so verbose, and so the rules get in my way, that as long as what you're representing is documented and understood, our plan, we actually did discuss this, like how should we represent this? I keep pointing at Christian, like I told you. But we talked this about a lot. We said, okay, if we do want to make this visible from something else, let's say for visualization tool, like we would build a layer and export it out.
Thanks, the method.
All right, there are 3 minutes. But just as an example of how this worked out, this is a little snippets from a notebook, but this is also the same code that would end up in our automation infrastructure and any of our activities. But it's meant to be very simple. Oh, we'll see how that does. But the idea in this case is just showing working with a data frame in Provenance. Very simple initialization that right now, when we started, I say right now, it's still going. Where we ended was that we didn't have a universal namespace for these sessions. It was sort of choose your own. But they were versioned and handled within Quilt and actually allowed you to run this session multiple times. But very simple, start your session within Provenance, create your data, let's say, and then register that data. I want to track this output. I want this to be part of my Provenance record. Just a simple call to the Provenance session. And you notice you get out of that a URI, which tells you where it's going to be. This would, upon commit, you notice that it's storing your data out in this case, the data frame out in our Provenance record. But there's not a lot to show here, except that it's simple. It's mentioned very easy. So the idea was that for more of the data science side, to be able to use this to make very straightforward calls, right? Not a lot of detail explore. So I actually just walked through this, like so this is my first time in this. I forgot I moved through these lower slides. So I'll stick through those. But I'll do it on this one because I did it again. Second, it's a quick example on this is, again, looking for your session. In this case, we have a session by URI. You're pulling it out for that test session. And from there, you can actually find different artifacts by different attributes. So you can load up. This is one of the side benefits we found in our Provenance, is enabling our data scientists to do this where they can store previous results of the Provenance system temporarily, pull it down, and use it to compare multiple runs and so forth. So it actually became a little bit of an investigation tool with them, one of the unexpected side benefits. And being able to inspect more, the example of pulling in the compute environment, being able to expect more about the data frame that you wanted to look at. Now, finally, if you want to get the data frame, you can just reference the final data frame and pull it back. So again, the API itself, choose your own API. Point is, make it simple, make it easy to navigate. These pieces of interaction were actually navigating the graph. So when you asked about how do we navigate it, we had our own API, right? So it wasn't perfect that way, but it was meant to be a very simple walk API. And that's it. I am at 30 minutes, but I think I'll fit. Questions, please ask. What our any tiers, please don't be afraid to ask us directly. Like, not just now, but after the fact, then does so. But, okay.
Can you talk a little about the anatomy of the URIs and if it was anything like, are they hierarchical? What did you think about in the design phase of the URI?
So, anatomy of the URI, correct. So, we use URIs in a lot of different places. In this case, the Celsius resource, what is that? Celsius resource
Number. Celsius resource number.
Wait, Celsius, sorry.
Celsius resource number.
Celsius resource number. Okay. So, so very high level. It was a basic. Okay, let's take a look at a namespace, but we did not predefine that namespace. So we went from a very high level. Okay, we have different initial ones that indicate what the start of the URI is, but then we just tried to provide it in a way that's very similar to our object model.
Yeah.
Right. So that's probably the closest analogies of the like design methodology of how you would do a class structure. But after that, we did have to take into account. So one thing to admit, we didn't ahead of time build like an ontology. I'm not a fan of that personally. I think you could spend 6 months a year defining your namespace, and then it's wrong. So we tried to make it same, but we didn't do it ahead of time. So we sort of built it out as we went with some forethought towards similar to an forethought on class structure. But then after that, we, as we're sticking with the URIs, we did a lot of stuff where the actual, it would identify what you're doing, where it is, but then there's a lot of parameters. So we heavily leveraged core parameters as essentially args. And so for a lot of things that were activity related, the args became core parameters. And that was a lot of things. So you could turn one of these into something that made it down to a function call, right, with specific args, which worked out really well on the left for us. So I don't know if that got too deep into what you're asking about.
Like,
Sounds. All right. Well, thank you.